It was the summer of 1943, and heavy fighting was underway around the Kursk salient. German heavy Tiger tanks, equipped with 88mm guns and reinforced armor, held the advantage in effective range. But as the battles raged, Soviet self-propelled guns with large-caliber weaponry appeared on the field. A direct hit from a 110-pound shell fired by one of these guns could inflict critical damage on German machinery. The sheer kinetic energy of the impact was enough to tear a turret right off its ring. German tank crews were facing a new threat from Soviet artillery. The German command had planned Operation Citadel with the goal of regaining the strategic initiative following their defeat at Stalingrad. They amassed a force of about 50 divisions on the Kursk Bulge, including 18 tank divisions. To break through the defenses and encircle the Red Army, they intended to use nearly 3,000 armored vehicles. A crucial role was assigned to the new Tiger and Panther tanks, whose frontal armor, up to 4 inches thick, was considered impervious to most anti-tank weapons of the time. The long-range guns on the German machines allowed them to hit targets from distances far beyond the reach of Soviet tanks. When the Soviet leadership received intelligence reports about the massive concentration of enemy armor, they realized the situation was critical. The T-34 and KV-1 tanks, with their 76mm guns, were outmatched by the new German models in long-range duels. As a countermeasure, heavy SU-152 self-propelled guns, armed with 152mm gun-howitzers, were deployed to Kursk. These machines had been developed and rushed into production just months before the battle began. The concept behind them took shape in the winter of 1941-1942, following the Soviet counter-offensive near Moscow. Planners of future offensives knew they would need to break through powerful enemy defensive lines, fortifications that included bunkers, trenches, and minefields. Destroying these fortifications required vehicles that could move in combat formation and fire via direct aim. Towed artillery, with its low mobility and vulnerability, simply couldn't do the job effectively right on the battlefield. In January 1943, the State Defense Committee ordered the development of a prototype for a heavy self-propelled gun. The project was led by chief designer Joseph Kotin, who was known for his work on the KV tank series. Because the front lines needed new equipment immediately, design time was short. Building a machine from scratch under those conditions was impossible. So the designers used the chassis of the KV-1 heavy tank, which was already in production, as a base. This saved time on testing the suspension and transmission. The main challenge was choosing the gun. Designers looked at various artillery systems, evaluating their power and how well they could be integrated with the tank chassis. They settled on the ML-20 152mm gun-howitzer, the 1937 model. It had the right characteristics to fire both on a flat trajectory for direct aim and on a high arc for indirect fire. Its shells weighed over 110 pounds and had immense destructive power. The design bureau built a prototype in just 20 days, an extremely tight deadline. On February 14, 1943, the self-propelled gun was officially accepted into service under the designation SU-152. The vehicle had a combat weight of 50 short tons. Inside the armored hull sat a crew of 5. A 600-horsepower diesel engine allowed it to reach speeds of up to 27 miles per hour on the highway. Its main weapon was a howitzer gun, with specs impressive enough to punch through concrete walls over 3 feet thick from a distance of nearly a mile. Production of this new self-propelled gun started immediately. Factories worked around the clock to flood the front lines with the new machinery. By early July 1943, the first batches of SU-152s were shipped to the Kursk Bulge. These machines were destined to face off against German armor, including heavy tanks. Command decided to use the self-propelled guns as anti-tank weapons, despite the fact that they were originally designed to demolish fortifications. On July 5th, the German offensive began. Large tank formations were sent to break through the defense. German tanks held the advantage in several technical areas. Specifically, the Tiger tank's 88mm gun could hit targets from 1.2 miles away, outranging many Soviet tanks. However, the math changed once the SU-152 appeared on the battlefield. When clashing with these heavy self-propelled guns, German equipment losses were significant. The concrete-piercing shell, weighing 106 pounds, with a muzzle velocity over 1,600 feet per second, packed massive kinetic energy. Even in cases where the armor wasn't pierced all the way through, the mechanical impact caused components and assemblies to fail. There were reports of welded seams bursting, armor plates warping, and internal equipment shattering from the shockwave. Crews suffered severe concussions. A direct hit on the turret often tore it right off the ring, leading to the total destruction of the tank. Ambush tactics proved highly effective. The self-propelled guns were stationed in camouflage positions on commanding heights or in forests along the predicted routes of Wehrmacht tank columns. Fire was opened when the range closed to about a mile. Taking out the lead vehicle usually blocked the column's movement. Subsequent shots disabled the rest of the equipment, limiting the enemy's ability to maneuver or organize return fire. Spotting the source of the fire was difficult due to the low silhouette of the vehicles. The power of the gun allowed it to destroy various armored vehicles, including Ferdinand assault guns with frontal armor up to 8 inches thick. For heavily armored machines, a hit from a 152mm shell often ended in penetration or critical hull damage, forcing enemy crews to move through rough terrain with caution. The combat qualities of the new self-propelled gun were quickly noticed by the troops, earning it the unofficial nickname Beast Slayer. During the Battle of Kursk, these machines took out a significant number of tanks and assault guns, playing a role in disrupting Operation Citadel. After the strategic situation on the Eastern Front shifted, the use of the SU-152 became widespread. Starting from the second half of 1943, the units were used in various sectors, from Leningrad to Crimea. Beyond fighting tanks, they were employed for their intended purpose, demolishing fortified defensive positions. Howitzer shells with a large explosive charge effectively destroyed permanent firing points and bunkers. The ability to fire a high-arcing trajectory allowed it to hit targets hidden behind obstacles, targets that were out of reach for the direct fire of standard tank guns. The units would move into firing positions, deliver artillery strikes on fortifications, and quickly relocate to avoid return fire. Being fully armored provided the crew with protection against machine gun fire and shrapnel. This allowed the SU-152 to advance to direct fire range to suppress enemy positions in situations where towed artillery would be vulnerable to small arms. Frontal armor, 3 inches thick, and side armor of 2.4 inches, provided protection against many anti-tank weapons of that period. The crew consisted of 5 men, whose duties were clearly divided. The commander directed the vehicle and observed the battlefield. The gunner was responsible for aiming the weapon. The loader handled feeding heavy shells into the breech, a task that required significant physical effort. The driver operated the vehicle and monitored its mechanical condition, while the radio operator maintained communications. The vehicle's combat effectiveness depended on the coordination of the crew. However, the SU-152 had a number of technical flaws inherited from the KV-1 tank chassis. The main problem was the design of the transmission with its steering clutches. This assembly didn't allow the full power of the 600 horsepower engine to be utilized, and steering required serious effort from the driver, especially when maneuvering over difficult terrain. Operating the levers demanded considerable physical strength, leading to rapid fatigue for the drivers. During long marches or drawn-out engagements, this created operational difficulties. The clutches were prone to overheating under heavy loads, causing premature wear and breakdowns. Repairing the transmission in the field was a labor-intensive process, requiring specialized equipment and skilled personnel. Vehicles often went out of action due to mechanical failures in the running gear, regardless of whether they had taken battle damage. This reduced the overall combat readiness of units and increased the burden on repair crews. Reports noted the machine's lack of reliability for conducting prolonged operations away from supply bases. Another significant design flaw was the poor ventilation of the fighting compartment. During intense firing, propellant gases would accumulate inside the vehicle. The standard ventilation system couldn't always cope with extracting them, especially at a high rate of fire. The high concentration of fumes negatively affected the crew's physical state, leading to the risk of poisoning and reduced performance. Periodically, it was necessary to pause to air out the fighting compartment, which was difficult in a combat situation. Physiological reactions, such as coughing and eye irritation, reduced the efficiency of aiming and firing. The ammo load consisted of 20 rounds, which met standards for the 152 mm caliber, given the weight of the ammunition, but their placement inside the limited space created ergonomic issues. Moving heavy shells from various storage racks required significant effort and time. This reduced the rate of fire as the ready-use ammunition was used up, and shells had to be retrieved from less accessible spots. Delays in the loading process could increase the risks for the vehicle and crew during a direct engagement. The production of the SU-152 was tied directly to the tank it was based on. By the fall of 1943, the decision was made to stop producing the KV-1 and switch to the new heavy tank, the IS. This platform featured stronger armor with rational slopes, more powerful weaponry, and a modern transmission with planetary steering gears. When production of the KV tanks stopped, assembly of the self-propelled guns based on them ceased as well. In December 1943, serial production of the SU-152 was completely wrapped up. In total, 670 of these units were built. The existing machines remained in service until the end of the war, with crews adapting to the model's technical quirks and flaws. But the need for a more modern technical base led to the development of an improved self-propelled gun on the IS chassis. In early 1944, a prototype was presented, designated the SU-152. Despite looking similar to its predecessor, the new model featured a number of design changes. Since the hull of the IS tank was lower, The height of the fighting compartment's superstructure was increased to fit the gun and give the crew decent working conditions. The armor protection was optimized by increasing the angle of the armor plates. This improved resistance to shells without increasing the armor thickness or the overall weight of the vehicle. The 3.5-inch frontal armor of the superstructure was positioned at a significant angle, providing protection against most anti-tank weapons of the period. Statistics show a reduced probability of penetration even by 88mm guns. A key technical change was the new transmission with planetary steering gears instead of side steering clutches. Handling the self-propelled gun became easier, which reduced physical strain on the driver and lowered fatigue during long drives. The vehicle's maneuverability increased, which was crucial in urban environments. The reliability of the suspension also improved, and breakdowns became less frequent, allowing the vehicles to make long marches and operate deep in the field, far from repair bases. The ventilation system in the fighting compartment was modernized by installing an additional fan, which cleared out gunpowder fumes more effectively during intense firing. The crew could keep shooting for extended periods without losing efficiency due to smoke, which helped maintain a steady rate of fire. Working conditions for the loader were improved, allowing for faster handling of shells. The ammo load remained at 20 rounds, but the storage layout was redesigned based on experience with the previous model, making access easier. The internal layout of the fighting compartment became more ergonomic, increasing the working space for each crew member. The SU-152s began reaching units in the spring of 1944, just in time for major offensive operations. These self-propelled guns were intended primarily for suppressing fortified defensive lines, which included layers of trenches and permanent bunkers. Storming such fortifications with just infantry and tanks involved high risks, so heavy SPGs were used to destroy targets with large-caliber shells. During an attack, while field artillery worked on rear positions, the SU-152s destroyed fortifications on the front line with direct fire. Concrete-piercing shells were used to demolish pillboxes, while high-explosive fragmentation shells were used to hit trenches and enemy manpower. This artillery preparation allowed advancing units to move forward while minimizing losses. The firepower often led to the retreat or surrender of the defending forces. The machines were also used when storming cities, where the enemy used buildings to organize defenses. In street fighting conditions, the self-propelled guns moved up to close range to destroy fortified points. The heavy shells punched through brick walls, neutralizing the personnel and firepower inside the structures. High-power, high-explosive shells smashed through building floors, eliminating manpower hiding inside. The howitzer fire allowed them to hit targets situated behind obstacles. In cases where the enemy was dug in behind stone walls or in courtyards, adjusting the gun's elevation allowed for plunging fire. This method was effective against infantry tucked into folds in the terrain or on the reverse slopes of hills. In situations unreachable by the flat fire of ordinary tanks, the SU-152s were brought in to solve the problem with a single salvo. The explosions of the 152mm shells created massive craters and inflicted damage within a radius of several dozen yards. Their level of armor protection allowed these self-propelled guns to operate on the front lines right alongside tanks. The frontal armor could withstand hits from 75mm guns from over 550 yards away, and at high angles of impact, it could even stand up to the 88mm caliber. Crew protection helped them carry out combat missions under enemy fire. Sniper and machine gun fire caused no harm to the armored vehicle. These self-propelled guns were also regularly used to fight armored vehicles during counterattacks. By 1944, the Wehrmacht's fleet was replenished with modified Tiger and Panther tanks, as well as heavy King Tigers featuring frontal armor up to 7 inches thick. For many Soviet machines, these models represented a serious threat, but the SU-152 possessed characteristics that allowed it to stand up to heavy hardware. Armor-piercing shells could penetrate the side armor of German tanks from a distance of up to 0.6 miles, while high-explosive fragmentation ammo could cause critical damage even without penetrating the armor. The tactics for countering German armor were systematized and refined. The vehicles were placed in camouflage positions along the enemy's probable routes of movement. Fire was opened on the lead vehicles from effective range, blocking the column's movement, after which the remaining targets were methodically shelled. The low silhouette and camouflage made it difficult to detect the units until the moment they opened fire. In defensive operations, these heavy self-propelled guns formed the backbone of the anti-tank reserve, moving out to threatened areas during breakthroughs. Their firepower allowed them to hold back large enemy forces with a limited number of machines. A single SU-152 unit was capable of inflicting significant damage on a tank unit before it could even get within effective return fire range. Command used these machines on the most critical sectors of the front. A significant role was also assigned to these units during the storming of European cities. During operations in Warsaw, Budapest, Vienna, Königsberg, and other cities, the SU-152s operated in the first echelons of the assault groups. Their cannon fire ensured the advance of attacking units, suppressing firing points and reducing casualties among the infantry. Defending garrisons used the urban landscape for resistance, but the technical capabilities of the self-propelled guns allowed them to overcome these fortifications. Intense combat actions took place during the storming of cities in East Prussia, where defenses with concrete shelters and barricades had been prepared in advance. The operation in Königsberg in April 1945 demonstrated the effectiveness of assault artillery. Heavy self-propelled guns systematically destroyed forts and bunkers, providing troops access to the city center. The capitulation of the garrison followed after the main defensive structures were destroyed. In April 1945, Soviet forces reached the outskirts of Berlin. The German capital had been transformed into a massive defensive stronghold, with an elaborate network of fortifications, barricades, and anti-tank obstacles. The German command was preparing for combat within a dense urban environment. Heavy SU-152 self-propelled guns were integrated into the assault groups deployed for the final battles of the war. On April 16th, the Berlin operation began. The self-propelled guns advanced in the first echelons, destroying fortifications on the approaches to the city. Despite the destruction of bridges across the Oder and towns turned into strongpoints, the vehicles were used to methodically suppress enemy firing positions. The guns cleared the path for infantry units and tanks. Their powerful shells demolished pillboxes and buildings where the defending units were taking cover. The street fighting in Berlin became a period of intense use for heavy self-propelled artillery. The urban environment, with its narrow streets and rubble, created favorable conditions for the defense. German troops put up stubborn resistance, using Panzerfausts, artillery, and sniper fire from cover at various levels of the buildings. The crews of the self-propelled guns fired on identified positions, securing a corridor for the advance toward the city's central districts. On May 2nd, the Berlin garrison surrendered, marking the end of the war in Europe. The SU-152 and ISU-152 models had been in service for a long time, from the Battle of Kursk to the capture of Berlin. These combat vehicles fulfilled their mission, playing a significant role in the outcome of the military campaign in this theater of operations.